Hi guys, it's Mrs. Seitz. Today what we're going to do is we're going to keep on working on those angle proofs today. So I wanted to add two more, one postulate for you guys to add to your list of reasons and another theorem that we're going to be adding to our list of reasons that we can use in proofs. And we're going to try out two proofs practicing those as well for today. So the postulate that we're going to work on today is called the linear pair postulate. And what it states is if you have two angles forming a linear pair, then they sum to 180 degrees. So if you have the measure of angle 1 plus the measure of angle 2, it has to equal 180 degrees. And the theorem that we're going to be looking at also today is the vertical angle theorem. So vertical angles are congruent. Remember, we worked on those before. So for example, the measure of angle D would equal the measure of angle B because they're across from one another, and the measure of angle A would equal the measure of angle C. So we're going to put this to some use now. So in this example, we have that the measure of angle 8 equals the measure of angle 5, and they're also giving us that the measure of angle 5 equals 125 degrees. We're trying to prove that the measurement of angle 7 is equal to 55 degrees. So right now I'm going to put in the information that I know, and I'm also going to write my given statement. So I know right now that the measurement of angle 8 equals the measurement of angle 5. So I'm going to draw some arc marks showing that. Okay, and the other thing I'm going to write down is that I know that the measurement of angle 5 is 125 degrees. There it is. All right, so it's 125 degrees. So I'm still working on trying to get that together. All right, so here's what I know. I know that I can say next that the measurement of angle 8 has to equal 125 degrees. And here's the reason why. I know that because you see this middle man here, the measurement of angle 5 and the measurement of angle 5 popping up here. I can use out that middleman with the transitive property of equality. I could take out the middleman and I can say that the measurement of angle 8 has to equal 125 degrees also. People can also argue that substitution property of equality too, because you're basically just plugging in 125 degrees in for the measurement of angle 5. Either way, it works. So I'm going to basically just put up here that I now know that this is 125 degrees for the measurement of angle 8. Okay, so now other things that I know. I know that angle 7 and angle 8 are going to be supplementary. Well, how do I know that? Well, when I look at that picture up there, by definition, that would have to be a linear pair because I have a pair of angles that are adjacent to one another and they form a straight line down at the bottom. So therefore, they have to be supplementary. So I am saying by definition, they are a linear pair. So I'm going to be using the linear pair postulate. Because I'm using the linear pair postulate, which is one of our new postulates up here at the top, so I'm saying if I have a linear pair, then they have to sum to 180 degrees. So because I'm saying that, now I can say the measurement of angle 7 plus the measurement of angle 8 equals 180 degrees. And that's by definition of supplementary angles. So again, if I add up angle 7 and angle 8, I get 180 degrees. All right, now the next thing what I'm going to do is I'm going to use some of this information. So pretty much what I've got going on here in step 2, I'm going to substitute in what I know here from step 2, and I'm going to underline that. I know that the measurement of angle 8 is 125 degrees. And I know if I add up angle 7 and angle 8, I get 180 degrees. So all I'm doing is I'm plugging in 125 degrees in for the measurement of angle 8 because eventually I want to end up with the measurement of angle 7. So by substitution property, I can plug in 125 degrees in for the measurement of angle 8. To get my answer for the measurement of angle 7, I'm subtracting 125 degrees from both sides. So because I'm subtracting, that's a subtraction property of equality, and I'm arriving at my answer for the measurement of angle 7 being 55 degrees. For our next proof, they're giving us this picture, and we're given that angle 1 is congruent to angle 3. So I'm going to mark that off. And I'm going to use these arc marks to show that. So angle 1 is congruent to angle 3. All right, I'm trying to prove that the angles across from it, angle 2 and angle 4, are congruent to one another. Now, it kind of looks like they should be, right? Because we have vertical angles, but we want to make sure that we get there in a sound way. Vertical angles are probably going to have to be used at some point, but we want to make sure we get there in a sound, logical way. So we got to state our given. So angle 1 is congruent to angle 3. Since we're talking about measuring angles, we should probably jump over to equality. So I'm going to say the measurement of angle 1 equals the measurement of angle 3, and that would be the definition of congruence, because remember, that's that property we used before that says I can get from congruence to equality or equality to congruence and switch over between the two. The next thing I'm noticing is from the picture, I know that if I say the measurement of angle 1 is now equal to the measurement of angle 2 because of vertical angle theorem, and I can also say the measurement of angle 3 equals the measure of angle 4 because those angles are across from each one another. So that's the vertical angle theorem. I'm almost there to what I want. I know I'm trying to prove that angle 2 is congruent to angle 4. And I kind of want to look at steps 2 and 3 to see if there's anything that I can kind of swap out to get to what I want. And I can kind of see it right now. I'm going to say that the measurement of angle 2 is equal to the measurement of angle 4. And here's how I can go about doing that. All right, if I look here, I know right now in step 2 that, let's see, the measurement of angle 1 was equal to the measurement of angle 3, right? And I also know right here, you can even argue transitive property here. The measurement of angle 1 equals the measurement of angle 2, right? So I could technically say here that I've got some things that I know right now that angle 2 has to equal angle 1. Angle 1 has to equal angle 3. And I can also make some statements there that angle 2 would have to equal some things with angle 4, right? Because if I know angle 1 equals angle 3, angle 2 would have to also equal angle 3. So I'm going to also use that statement with down here, right? So I kind of almost like cutting out the middleman here almost with angle 3. So this could also be argued, like I said, with transitive property, okay? But I'm going to think of it right now with substitution property of equality. But again, I can see the argument for the transitive property of equality because we can be cutting out the middleman, which would be the angle 3. All right, so I'm going to say angle 2 is equal to the measurement of angle 4. Then I want to get switched over to angle 2 is congruent to angle 4 because of the definition of congruence. So again, anytime you can see a middleman or anytime you can plug something in, sometimes substitution property and transitive property of equality can be interchanged a little bit whenever you're talking about equality. But when we're talking about congruence, though, you have to remember congruence, you can only use the transitive property. There's not a substitution property of congruence.